Okay. All right. So now this question says ZCCM is a major supplier of iron ore to the steel industry, and company is the fourth largest supplier of seaborne iron ore in the world. The company exports over 34 million tons per year. The company reserves amount to over 1 billion tons. Kongola Copper Mine presented a major expansion mining project for ZCCM. This CM is considering a new project with an expected life of 3 years. So our end is equal to 3 years. Okay, and expected to result in sales revenue of 20 million. Sales is 20 million in year one. And then we have sales, okay, of 30 million in the second year. That is 30 billion. Okay, so 30 billion in year two. And again, sales of 10 billion year three. Then operating costs amount to 70% of sales. Okay. So we can start solving now. So we just need to do the workings. So for the workings here, we are going to have sales year one. We are simply saying our base, so I'll just put, okay, so instead of 20 billion, I'll just simply say 20 million. I'll remove the 3 zeros, I've rebased. Year two, the sales is 30 million. Then year three, the sales are 10 million. So these are sales revenue. Let's go for operating cost. So operating costs, year one, we look at 70 over 100 times 20 million. Why? They're saying operating costs account to 70% of 70% of sales. Okay, so year three, 70 over 100 multiplied by 10 million. So for the first one, 0.7 times 20. So you see it's giving us 14 million. Okay. This one is 21 million. Then this one is 7 million. So let us now find net sales. So net sales year one will be 20 million minus so this is sales revenue minus the costs. So the cost for year one is 14 million. So meaning this one will be 6 million. Then year two is to be sales revenue of 30 million. minus 21 million, which is 9 million. Year 3 will be 10 million minus 7 million cost. So this one is giving us the 3 million. So I'm sure you have understood what we are doing here to get the net sales. Okay, so from here, the question was saying, okay, these were sales in the second year, third year operation cost was 20% of sales revenue. And then the company is required to make an investment in working capital of 6 million at the beginning of the project, which is year 0, which is recoverable at the end of the life of the project. The cost of the project is 18 billion, and the residual value at the end of the year is 11 billion. So we can now do the computation here. So we are going to have this kind of, so we are going to have the year. So year 0 is 0, okay? Then year 1, year 2, year 3. At the end of the year or the end of the project life, there are 3 things that are happening. Okay. So we have this one here. So what is going to happen here? There is what we call narration. We have a narration here or description. Then we have amount. Then we have the discount factor. Then we have the present value. We have what we call present value. Okay, so this is the project cost. Year 0, working capital, net sales, you have net sales. Okay, so net sales. Here we have also net sales. Amount is 18 million. From this one. All right, so we have 18 million. That was a project cost. Then at the beginning of the project, we have okay, government is going to make an investment in working capital of 6. So 6 million, I'm just rebasing. So you can put the 6 million here, working capital 6 million. So you have a 6 million here. The net cash flow year one, net cash flow year one is 6 million. We have 6 million here. Year two, 9 million. Year three, 3 million. All right. So what else are we having here? We're having year three. Okay. So for year three, we're having the other aspect here that we need to know. We have the recovery of working capital. So here year three, we have residual value. Again, on year three, we have recovery of working capital of 6 million. Residual value was 11 million from the question here. So what you are simply saying is that okay, so the project cost is 18 million or 18 billion, and the residual value at the end of the 3 years is 11 million. So this is money that you can recover. Residual value is what remains from the project. Residual value is what remains, okay, from the project. All right, so we have that one. Okay, so 18 billion, 18 billion, 11 million is what remains. Then at the beginning of the project, the working capital is 6 million additional, which will be recoverable at the end of the working project, which is at the year three, because this project was there only for 3 years. The cost of capital is at 14%. So we need to find the net present value of this project. All right, so this is what we are doing now. So the net present value of the project, we are going to have present value interest factor 1 plus r to the power negative n. Okay, so this one will be 1.14 to the power negative 0, which is 1. Same as this one will just be 1 because it says 0. 1.14 to the power negative 1. 1.14 to the power negative 2. Then 1.14 to the power negative 3. 1.14 to the power negative 3 again. So this is at the end of the 3. 1.14 to the power negative 3, 0.675. So 0.675, 0.675, 0.675, 1.14 to the power negative 2, 0.769, 0.769. Okay, 1.14 to the power negative 1, 0.877, 0.877. So this one will multiply to give us 18 million here. This one will give us the 6 million. Then here 6 million by 0.877, 5 million 262,000, 9 million by 0.769, 6 million 921,000, and 3 million by 0.675, 2 million 025. Then the other one is 11 million by 0.675, 7 million 425,000. Then 6 million recovery of working capital by 0.675, 4 million 050,000. So our NPV in this case is equal to the sum of present values of all cash flows minus the initial investment in a project. Okay, so it's the sum of present values of all
Mr.
cash
Sten.
flows minus the initial investment in the project. So that
Hello?
one plus 7,425,000 plus 2,025,000 plus 6,921,000 plus 5,262,000. Okay, then minus those cash outflows. So it's giving us 1,683,000. 1,683,000. That is it, the NPV. So NPV is equal to sum of present values of all cash inflows minus initial investment in a project. Initial investment in a project. Okay. So accept project if NPV is greater than 0. Otherwise, reject the project. Reject project. Okay, so this is what goes on. So meaning that we are just summing up these amounts minus the outflows. Okay, so that is it, what we have here. So this question came from this question here for capital budgeting. So this one is only what we call capital budgeting question. Okay. All right, so we have the information here. We have the project cost of 18 million. For those who are just joining in, we have analyzed this question. Sales revenues were given, okay, for the first year 20 million, second year 30 billion, but I replaced third year 10 million. Okay, operating costs amounted to 70% of sales. So we had to, and then investment in working capital at the beginning of the project of 6 million, which was recoverable at the end of the life of the project. Okay. And then the cost of the project was 18 million or 18 billion. And the residual value or scrap value. Residual value or scrap value is what remains to the project. That's other money, which was actually 11 billion. All right. So this is the question now. Then he wanted us the cost of capital was given. Okay. So we have the cost of capital is 14%. So 14% was the cost of capital. So what happens here now? So we have answered the first part of the question. Accept the project if the NPV is greater than 0. Otherwise, reject the project. So these are working. The working is for the net sales, sales revenue minus costs. The costs were 70% of sales. Costs were 70% of sales. Okay, so this is what we have. And then the net sales, we quote these ones as net sales. All right, so then we have the NPV, which is this one. Accept the project if NPV is greater than 0. So it's a sum of present values of all cash flows minus the initial investment in the project. Let's see the NPV. Accept the project if NPV is greater than 0, otherwise reject the project. Now, we are to get to internal rate of return. Internal rate of return is equal to L1, which is rate 1, plus NPV1 over NPV1 minus NPV2, then V2 minus A1. So this is our internal rate of return. So this one uses two rates and two NPVs. Okay. Now, NPV2 should always be should always be negative. Always be negative. So to get negative NPV, negative NPV2, set rate 2 as higher as possible. The higher the rate, the smaller the NPV. So the higher the rate, the smaller NPV. So we're going to find this in set rate 2 at, so set rate 2 at 30%. Okay? Away from 14%. So meaning you're going to have the year here, the same one data that we have 0, 0, 1, 2, 3, 3, and 3. So for this one, we have the aspect where, okay, so we have these ones. So we have what we call the narration or description. So this was project cost. This is working capital. Then here, what are we having? net sales. We have net sales, net sales. Then what are we having here? Residual value, recovery for working capital. All right, so here we are going to have amount. So we're going to find NPV2. Okay, so amount was the same, 18 million that we invested.
Mr. Sten?
Yes, boss.
Okay, just a credit. I've noted on the working capital there, there's 6,000, and then recovery of working capital 6,000. So how do you go about it? Because those two, they cancel themselves, or do you have to like just add the just go back again?
Okay, so let's go through. Let's go through. That's a good concern. So let me explain it so that we can be clear. Okay, so you are able to see the question also.
Yeah, yes, sir.
So I want you to be clear. Thank you very much for that question. Let me clarify. Let me explain why it's supposed to be the way I'm treating it. So the thing is like this. If you can see from here they're simply saying the company reserves account for over 1 billion tons. Konkola KCM presented a measure. Now saying this is considering a new project with expected life of 3 years and they expect to generate an increase in sales of 20 million in the first year, 30 million in the second year, 10 billion in the third year. Conversion costs account for 20% of the sales, and the company is required to make an investment in working capital at the beginning of the project, which means this is at year 0. Okay? You make an investment in working capital at year 0. Then you recover it in year 3. So you cannot cancel each other. Because this one, the discount factor is you're using, that's why we said 1.14 to the power negative what? The power negative 0, which was 1. Is that okay?
Yes,
Okay.
it's clear now.
So here,
Yes, very clear now.
the discount factor is 1.14 to the power negative 3. So it cannot cancel itself. Because you are multiplying it, but you are recovering it at the end of at year 3, at the life of the project, right? Okay, so it which is recovered at the end of the life of the project, which is at year 3. So that's why we had to, it cannot cancel itself. You get my point, right?
Yes, it's very clear now. It's very clear. Thank you so much, sir, for that.
This is why we multiplied it by, it was recovered, it was working capital. It had a 0.675 as a discount factor, not the 1. Okay, it wasn't recovered within the year, but it was recovered at the end of the life, so it was multiplying it by this discount factor. So here we are trying to use rate 2 as higher as possible. So rate 2 in this case, we are using, let's use the 30%. Use a very high rate. Even if they don't give you an exam, just try to use any rate that is very high. If they are giving you the tables, use the last figure that is there in the table. So here, the net sales here, we had what? The net sales quickly, we had 6,000,931 and 6. So here, these ones, we have 6 million, 9 million, 3 million, 11 million, and the recovered working capital is 6 million. So this is discount factor 1.3 to the power negative 0. So 1.3 to the power negative 0 is actually what? So this is what we are doing. So 1.3 to the power -0. The answer is 1. So even here, since it could be raised to the power -0, it's 1. 1.3 to the power -1. 1.3 to the power -2. 1.3 to the power -3. So 1.3 to the power 1.3 to the power -1, 0.769. This is the 0.769. Okay, 1.3 to the power -2, 0.592. 1.3 to the power -3, 0.455. 0.455. Even here 0.455. 0.455. So here, as you multiply this other side, present value will give us 18 million. Then this other one was to give us 6 million. Then 6 million by 0.769, 4 million 614,000. 9 million by 0.592 is 5 million 328,000. 3 million by 0.455, 1,365,000. 11 million by 0.455, 5,005,000. Then 6 million by 0.455, 2 million 730. So our NPV here is actually going to give us the okay? Then 1,365 plus 5,328 plus 4,614. Okay, minus those ones there. So it's giving us minus, which is -4,958,000. So negative. So even if we had used a 20%, if B2, if rate 2 was 20% and gave us the negative NPV, the internal rate of return has a range. There's no one single number because somebody can use 30%, 35%, 40%. I'm sure you get what I mean, right?
Yes, sir.
Okay.
Yes, sir.
So you'll give a range. So it's not one, but the range should be within the certain range. You know what I mean? So it shouldn't be, the variation shouldn't be too much, okay, from the percentage that they were allocated. So if somebody can use 20%, if the internal rate of return is 18.5, somebody can find 18.7, 18.9, or up to almost 19 against 2 marks. So this one was 1,683,000, NPV 1,683,000. So this is 1,683,000, 683,000 over 1,683,000 minus 4,958,000. thousand. Then here 0.30 minus 0.14. So our internal rate of return will give us what? 0.14 plus this other side you can sort out. 1683,000 over the total here is 6,641,000 multiplied by 0.16. Then plus 0. So it's giving us 18.05. So internal rate of return is actually giving us 18.05%. So our conclusion is that, okay, accept project if internal rate of return is greater than cost of capital. Okay, so what we are simply saying, 18.05% is greater than 14%. So therefore, accept the project. Accept project. Okay. So this is what goes on this one. Is that okay? So this is it, how this question was supposed to be answered. Okay. So this recording will be shared.
Thank you.
Unless otherwise. So use internal rate of return. Should they accept the project? Yes, because we have NPV greater than cost of capital, NPV greater than 0, NPV greater than 0, internal rate of return greater than 14%. So therefore, accept project. Accept what? Project. So we end here for now. I'm sure this recording will be shared. Is that okay, Mr. Clement?
Yes, thank you so much, sir. Thank you. Thank you. It's very clear.
You're welcome. You're welcome. So this you should accept the project because of whatever you have found so far. So this is why we end it on this question. Okay. So for those who joined late, the recording will be shared, please. So this is what was going on.